about functions of two variables. And we have to look at 4 sections from 6.1 to 6.4. First of all, how will a function of two variables look like? Something like this. An example. So this is an example of a function of two variables, x and y. Okay, I would like to discuss these functions, but I'd like to start with 6.4, which is the easiest possible section. In 6.4, we're talking about linear and exponential regression. So I'm going to talk a little bit about linear, and then with the graphing calculator, we will address problems from both. So let's suppose you become a data analyst and you collect your information or you collect your data and you get something like this. And you're plotting the points and you get something like this. It appears to be a linear trend. And you want to determine the line of best fit. Line of best fit. Because the model appears to be linear. Well, what does that mean? It's a line that will not go through all these points. It may not go through any, but is the line that has the least error. Line with the smallest, and that's why calculus comes into play. Smallest, we minimize the error. Line with the smallest error. There is a theory behind it, and it's all based on calculus, how this line is determined. The same thing, we can have an exponential model. So for example, let's say you're plotting the points this time, and a line will not go through all this. It will not go maybe through any. But it's obvious that this is an exponential fit. And it's all based on minimizing the error. So the line is determined in such a way that the error is smallest. The graph or the function that is exponential, it could be decreasing or it could be increasing, is determined with a minimum error. But there is no need to do all these calculations by hand. They are very time consuming. So I'm going to show you with a graphing calculator how to determine either one. I mean, we're going to have examples from both. And they start on page, if you have your book, or you can go page 553. Okay, so let's start with an exponential model, page 554 actually. I'm going to copy the data for you in case you don't have the book, or you can get to the multimedia library right away in my lab math. So let's look at, let's start with number 6. We are told to find an exponential regression curve. So find basically the exponential function or model or the curve. And they're giving us the data. They say x and y, 1 and 8, 2 and 25, 3 and 72, and 4 and 225. These are the ordered pairs. Stop me if you have questions anytime, please. So we'll go to stat. We're going to use the edit number 1. And in list L1, I will put the values of x. In list L2, I will enter the values of y. in the same order, 1, 2, and so on and so forth. 1, 2, 3, 4. List L2, 8, 25, 72, 225. Once I have the data entered in list L1 and list L2, you can get out of there with second and quit and go to stat. And this time we are going to perform some calculations. So move across to the right to calculations. And in my calculator, linear regression line is number 4, but we are interested in exponential regression. Older calculators may not have this feature.
Can you go back after second quit, then which one do we hit?
Go to stat.
That?
And then across to the right to calculations.
Okay.
And I was just showing that the linear regression that we are going to use in a minute is number 4. Mm-hmm. But the exponential regression is number 0. Again, older calculators may not have it. So click on exponential regression. It's already ready for us with list L1, list L2. If you used it before, just make sure you're using the correct lists. I don't know where you entered the data. I entered it in a list L1 and a list L2. Now, if you have this type of calculator, it says store the regression equation because I may want to graph it. So I don't want to enter it by hand. So it gives me this option. So I'll go to variables, across to y variables, press on function, and I prefer to have the function in y1. So the calculator will create this function using the exponential regression, using the points, creating the minimum, determining the minimum possible error, and it will store the equation at the same time in y1. And now I go to calculate and press enter. So the exponential regression model will be y, or if you want f of x, same thing, which is a, which is 2.67 approximately, times the base, which is 3.025, raised to power x. I already asked the calculator to save this in y equals. So I have it already in y equals. And I want to graph it for x between, let's say, -2 and 6. But careful, y goes from 8 to 225. So let's go to window. I can use zoom fit, but I prefer having control over this. So let's say -5 is fine, but at least, let's say, 6 or 7. And the y minimum with a scale of 1 is fine. Y minimum, 0, but y maximum has to pass this value. So I'm going to put 230. And with a scale of let's say, 50. At this time, I will press graph. And here's the graph of the function. Increasing with a base greater than 1. Did I have anything else? No, I did not have anything else in there. With a horizontal asymptote y equals 0. So this is this model. That's how we get the linear regression, the exponential regression. In the same way, identical. Let's say life expectancy of men. One more time, page 554, both of them. And we are given the table, and we are asked to find the linear regression line and use the regression line to predict life expectancy, such and such. So this is the number of years. X is the number of years since 1990. So x equals 0 represents 1990. That's my, for my, so I don't forget. So I have 0, and I have 10, I have 13, I have 17, I have 21 for x. And then y, life expectancy, 71.8, 74.1, 74.8, 75.4, and 76.3. Now they're asking us to find what happens in 2020 and also 2025. In addition, so this is part B. In part A, they wanted a linear regression model. So I go back to stats, edit. I don't need the first two lists, so I'm going to clear them. You clear them by highlighting the top and just pressing clear. So clear and enter. I will enter the X values first, 0, 10, 13, 17, and 21. And I will enter 71.8, 74.1, 74.8, 75.4, and 76.3. I'm checking my numbers. Yes, that's okay. 71.8, yes, 74, 74.8, yes, 75.4, and 76. Perfect. So second and quit, we go back to stats and back to calculations. And this time we're going to use the linear regression model because that's what we are told. We can plot and see that that's true, but we are told it's a linear regression model. Just find it. So the two lists are there, list L1, list L2. I want again maybe to graph. So I'm going to ask the calculator to already put it in. So variables to the right, function, I want it in Y1, and I want to calculate. So here is the linear regression model. So it's y equals, or f of x equals, same thing. A, 0.213 x plus the y-intercept, the slope is 0.213 and the y-intercept is 71.88. 71.88. If I want now to graph this function, just to see what I determined in case I needed, I'm just going to have to use the window again, make sure that x is somewhere between 0 and 21, make sure that y is somewhere between 60 and 80. So 0 to 21 with a scale of 3. And y minimum, 60 is enough. Y maximum, 80 is enough with a scale of 2. And then when I hit graph, I will see the function. I have to see why my calculator shows that shading. I'm not sure. I have to dig something up there. I'm not sure how it got that all of a sudden. Okay, so this is the line. It's the linear regression line. It has the least error possible. Now they're asking us for what happens in 2020 and 2025, assuming that the model still holds. Now, before we go back to the calculator, I need to say the following. So if x equals 0 represents 1990, the year 2020 is x equals 30. There is a problem here because x equals 30 is outside of the range. I don't know if the trend continues. Look, there is a pandemic. So anything can happen, right? So normally we don't like to predict outside of the model because it's not safe. We don't know if the model will still be valid. The same thing for 2025. So 2025 represents x equals 35. We're going to look at it, but just remember moving forward that it's normally not okay to go outside of the range. You can say domain. Yes, it's the domain, which is values of x, but outside of 0 to 21, it's not safe to predict. Or we have to say if the model still holds. So now we already have the function in y equals. So just go to second and table. and just plug in 30 and 35. So 30 enter, 35 enter. So when for x equals 30, I will write f of 30 is 78.268. I copied everything I saw there. And for x equals 35, f of 35 is 79.332. Of course, the measurement unit is years. That's basically all I had to say about section 6.4. I just wanted to get it out of the way quickly. I'm not going to ask you to determine the regression or the exponential model by hand. The calculations are long. So that's all I really needed about 6.4. Just to show you where to find what we needed to calculate, how to enter the information and how to get the model and how to predict. We are not very happy with predicting outside of the study. Okay, so now we go back to section 6.1 through section 6.1 through 6.3. Okay, so back to functions of two variables in this section. Page 531. And I would like us to start with evaluating. Very simple, of course. So let's say problem 6. We're given a function of two variables, x comma y, and we are told that this is 2 to the x minus 3 to y, and we're asked to find several values. So we're asked to find f of 0 comma 2, f of 3 comma 1, and f of 2 comma 3. And this is not a big deal at all. I'm sure you understand. So f of 0 comma 2 will be 2 raised to 0 minus 3 raised to 2. 2 raised to 0 is 1. 3 raised to the second power is 9. So this must be negative 8. The next one, f of 3 comma 1, will be 2 raised to 3 minus 3 raised to 1. So this is 8 and minus 3, which is 5. And last one, f of 2 comma 3, just evaluating, so we know how to evaluate functions of two variables. So this is 2 to the second power and minus 3 to the third power. 2 to the second is 4, 3 to the third is 27, so this must be negative 23. Okay, so let's look here. There is nothing else here, just evaluating and also finding domain. And then we can look at some applications. Let me see how I'm on with time on this.